Hello again, everybody. Alright, so here we are with another section of the integumentary system. In particular, this video is going to be about hair's anatomy. So, we have here an image of skin. There's the epidermis portion, here's the dermis portion, and here we have one hair, or pilus, sticking out of it. Now, hair, like skin, is made up primarily of keratinocytes, dead cells. The only living cells are the ones that are found in the deepest portion of the hair. Okay? So hair, skin, and nails are all pretty much of the same kind of material. Keratinocytes, cells that are packed with tough keratin that give it some of its more structural strength. Okay? The keratin inside of hair and nails is a slightly harder kind than the stuff that you find in your skin. The stuff in your skin is called alpha keratin. The stuff in your hair and nails is called beta keratin. It has sort of cross links between the keratin fibers, so they're almost organized a little bit more like ladders as opposed to just the side-by-side fibers that you would find in skin keratin. Okay? But every single hair grows out of a tube of reproducing cells that's called the follicle. So if the hair is removed, then the follicle remains. Okay? The only places that you're not going to be able to find hair on the body are the thick skin areas, so palms and soles, but also certain other specialized areas, like for instance your lips, the surface of your eyelid, and the lateral edges and dorsal. I guess it's the dorsal side of your fingers, or particularly the fingertips. There may be some hairs in the middle bone of your fingers, but that's one of those genetic quirks. Some people have it, some people don't. Let's see. Over the course of a lifetime, a human's going to grow 3 different kinds of hair. The first kind is called lanugo hair, L-A-N-U-G-O. Right, let's just that. Current slide. Right. Lanugo hair is fine, downy, unpigmented hair that appears on the fetus in the last 3 months of development. So most of us never really see it, but by the time the child is born, a lot of that lanugo hair is going to be replaced with vellus, fine pale hair that replaces the lanugo by the time of birth, but then that stuff persists. Right? On, say for instance, the surface of your cheek, you can probably feel a little bit of fuzz there. That is vellus hair, fine pale hair, and that typically doesn't have any pigment to it. Children have loads of this stuff, except for eyebrows, eyelashes, and hair of the scalp. Now, once you're an adult, then you're going to be growing a lot more of the third type of hair, which is this one, terminal hair. Terminal hair is longer, coarser, and usually more heavily pigmented. Just depends on what kind of pigmentation your integument has anyway. But forms eyebrows, eyelashes, and the hair of the scalp. After puberty, forms the axillary and pubic hair. So axillary hair is found in the armpit. Pubic hair is found in the groin, in the pubic region, and male facial hair, and some of the hair on the trunk and limbs. Particularly men may have more hair on their arms and legs. That is also more terminal hair. And let's see. Okay, so getting back to the structures of one hair. I tend to designate this in terms of sections of the hair, based on where they are in the skin versus the layers of a hair, which you might find, let's see, in an image like this one, where you see a cross-section of the entire thing. Okay? So the sections of the hair include the hair shaft, which is everything that is superficial to the epidermis. Then there is the root section, and let me just make sure I've got these highlighted. So here's the shaft portion from there to there. And then the root portion is everything from here to here, all the portion of the hair that is buried underneath the surface of the skin. Right? But the bulb is this part. Right? The hair bulb is just the deepest portion of the root, and that is where you're going to find the rapidly reproducing cells, the living cells. The rest of the root and all of the shaft is made up of the dead keratinocytes. Okay? And of course, the entire hair is stuck within the follicle. So this means, let's see, we should also define some components of the bulb a little bit further. So let's pick a different picture. like this one, right, and wipe those off. There we are. Okay. Inside the bulb, there's going to be a little bit of dermal tissue. It's a papilla, like the papilla that you see up here from where the dermis kind of pokes up into the epidermis. There's also one of those down here inside the hair bulb, and so it's called the hair papilla. Right? Inside of that hair papilla, there's a little bed of capillaries that are going to provide blood and nutrition to the living cells of the hair bulb. Those living cells are dividing mitotically. They're stem cells, kind of like the same ones that you found in the stratum basale, but in this case we call that particular region the hair matrix. Right? So you've got the reproducing cells here in the hair matrix, and they'll primarily be stem cells that will then turn into keratinocytes that grow through the rest of the hair, but there will also be melanocytes found in this area, which is why hair is going to have colors. And, of course, you've got your wide variety of hair colors. You've got your brunettes, which are going to have more eumelanin in them. Then you have your reds and auburns, which are going to have more pheomelanin. And then you have your blonde individuals who are probably going to have relatively little amounts of both eumelanin and pheomelanin. So just less pigment, basically. Let's see. All right, so that dermal papilla provides the hair with nutrition, and immediately above the papilla is the hair matrix. Alright, when you go through the cross-section now, there we go. When you go through the cross-section, you find that there are 3 layers of tissue that make up a hair. Centrally, there is a medulla. That's in a sparsely populated empty space. It's like an empty hollow center, but there may be some protein fibers and a few scattered cells within it. But the medulla in other organs is the hollow center. Then the cortex portion of a hair is where you're going to find the greatest concentration of cells, usually densely packed cuboidal cells. That's where most of the pigment's going to be found. And then superficial of that is where you find the cuticle. The cuticle is going to be lots of, a few layers of stratified squamous cells that overlap one another on the surface like the shingles of a roof. And I've got a couple images of that one here too. There we go. Yep. So here's the surface of the hair, and you can see right there those edges that would indicate the nature of the cells. Here's another one, so you can see the hair has kind of a very scaly appearance to it. Right? Here's another one. Is that one? This? Okay, I'll just stick with that one for now. Go back to this one. All right, and those squamous cells are some of the things that help to affix the hair inside the follicle, so it's difficult for it to be pulled out. Okay. So right here you can see the squamous cells of the epidermis. By here I mean right here, there we go. So here are the cells of the epidermis, almost like petals around a flower of some sort, and then here you have the squamous cells on the surface of the hair, with their free edges facing in a superior direction. So if you try to pull the hair out, those edges would catch on the sides of the follicle and makes it more difficult for it to be removed. Right? And here's an even closer view of those things up here. Alright, so let's see. Inside the hair, however, you're going to have the medulla in the center, cortex around that, and then a superficial cuticle. Right, now we need to take a look at the structures of the follicle itself. For that I need which image? Right, one like this, or actually which one is even better? This one again. Right. See, the follicle remains if the hair is removed. And this right here in purple, this region right from about here to here, right, that is a section of the follicle that's called the epithelial root sheath. It's also made of stratified squamous epithelial cells, kind of like the very surface of the skin. Right? And it's also helping to hold the hair in place. But if you go outside of that, then this tissue, from here to about here, right, that's called the connective tissue root sheath. It's made of the same kind of tissue as your dermis. Dense, irregular fibrous connective tissue serving as a place for these epithelial cells to hook onto. So, epithelial root sheath will be just outside the hair cuticle, and then the connective tissue root sheath will be just outside the epithelial root sheath. And if you pull the hair, both of those sheaths will help to maintain the shape of the follicle while a new hair grows from it. Let's see. Now, the rest of the follicle is usually organized as a diagonal tube inside of the dermis. And back to this one. But the angle of that follicle can be changed because of these little muscles that are connected to it. Right here, you have something called a piloerector muscle, a small bundle of smooth muscle cells that connect between the root, or technically the follicle portion of the hair, and some of the dermal fibers, so that when it contracts, it will pull the root of the hair slightly upwards, which would make a bulge in the skin, and that is the goosebump that people then experience. But also, it causes the hair to stand a little bit more erect as it's pulled in this direction. So consequently, your hairs now stick away from the surface of your body a little bit further and increase the aura of sensitivity that you possess. Okay? And that term, goosebumps, could also be described as horripilation, Horripilation. And horripilation basically translates to horrified hair. Let's see. So now is probably a good time to consider why we have hair at all. Okay? We are not as hairy as our ancestors were, and so consequently, the job of maintaining heat no longer really applies to human hair. I mean, true, we do have a couple places where the hair is relatively dense, primarily one's scalp. Maybe you, but not me so much. And there it can retain some heat a little bit better. But nowadays, the hair that's found all over a human's body is mostly there for sensory purposes, because every single hair has wrapped around its root a hair receptor dendrite. So this line right here that's connected to it, that is the dendrite of just one neuron covering over this thing, so they can tell if the hair has been pulled in any fashion. And then when it does send a signal straight off to the brain. So of the multiple thousands of hairs that you've got, every single one can send a signal to the brain saying that it has been moved in some fashion. So that's an awful lot of sensory capability beyond what you already get from the touch sensors that are in the surface of your skin. Okay. So let's see. So the main reason to have hair nowadays in your modern human is really for sensory purposes, but there are also a couple other places where the hair is going to be valuable, including where you have guard hairs of the body. Let's see. Functions of hair. Here we go. Guard hairs are also known as vibrissa, V-I-B-R-I-S-S-A-E, okay, which can then guard nostrils and ear canals, basically serving kind of like a sieve that can prevent large objects like debris or maybe even whole insects from getting into those small openings. Okay. There are some places on your body where the extra hair will help to prevent sunburn, in particular your scalp. Right? And pubic and axillary hair, again that's the armpit hair, can signify sexual maturity and aid in transmission of sexual scents. Because later on we'll talk about how the glands that are associated with your skin, the ones that produce scents, your pheromonal apocrine sweat glands, they're typically associated with places where you have thick quantities of hair. Right? And then we also have some specialized hairs like eyelashes and eyebrows, which serve the purposes of helping to screen debris from your eyes, particularly if you're squinting. And also, your eyebrows can help to deviate sweat that might be coming down your forehead off to the side so it doesn't pour directly into your eye and sting terribly. Okay? So most of your hair is sensory, but there is some limited protection function in the regions where certain hairs are particularly thicker. Okay, okay, so let's see. Anything else? Oh yes. Hair is going to be growing from your body according to a sequence of events, a hair cycle. Okay? Skin doesn't grow in cycles. You pretty much just have a constant reproduction of cells coming up from the stratum basale, pushing older cells towards the surface. The further away they get from the blood, then the fewer nutrients they get. Once you get to the stratum granulosum, which also secretes a waterproofing layer, then no more nutrients can get to cells. Higher than that, the cells die. Well, here we start off with cells in the hair matrix, down at this spot, that are going to be grown further and further away from the blood vessels that are in the hair papilla. So most of the hair material is dead from the slightly deep and superficial portions of the root all the way to the shaft. It's nothing but dead cells. So the follicle is what's really going to be driving the growth of the hair. right? And of course the hair matrix down here by the hair papilla. So the three stages of growth for hair are anagen, A-N-A-G-E-N, catagen, C-A-T-A-G-E-N, and telogen, or telogen, T-E-L-O-G-E-N. These three phases represent hair growth, then a degeneration of the follicle and the cessation of growth of the hair, and then a waiting phase where nothing really much is going on to the hair. This is the space basically that's between the last catagen and the beginning of the next anagen. Right? But during the anagen phase is where most of your hairs are right now, about 90% of them. So they're actively growing. The blood vessels are feeding the hair matrix, multiple keratinocytes are reproducing, melanocytes are producing pigment for your hair, and the hair grows through the follicle. And this goes on for approximately 6 to 8 years for your average individual. Yes, there are people on either side of that average. Some people can only grow their hair for maybe a year at a time, or 3 years at a time, and then there's some people whose hair never enters the catagen phase, and so one follicle can grow technically forever, for as long as the person is alive. But those are the extremes. Most of us can only grow hair, if you can grow hair at all, for about 6 to 8 years. So at the end of an anagen, there will be a reduction in blood flow in the hair papilla, and so as a result, the hair matrix stops reproducing. The remainder of those keratinocytes, they die, and now the follicle itself degenerates. It narrows inwards, and the papilla stays down here, while the rest of the hair is sort of displaced upwards, and so we call this thing the club hair. Right? The follicle cells, the ones that form the epithelial root sheath, well, they kind of degenerate also, but they're still there. They haven't gone away, and this catagen time takes about 2 to 3 weeks. Then you have your waiting period, where nothing goes on. At the end of and that is your telogen phase. At the end of the telogen phase, we see some activity happening in the epithelial root sheath. Stem cells here are going to start to reproduce faster. And now we see this bulge of the follicle start to grow wider, and it is also going to start to descend in a deep direction in the skin. So instead of being this shortened follicle, it starts to get longer, and at the same time, there'll be more blood being provided to the hair papilla, there'll be a regeneration of the hair matrix cells, and a whole new hair will start to form inside the follicle. And as the new hair forms, it's very likely to push the old hair out. And so your club hair falls out. And on average, I believe, your typical human loses about 100 hairs from the scalp every single day. With some variations, of course. In fact, this is kind of an interesting thing. A woman who becomes pregnant has an awful lot more steroid hormones that are going to be flowing through her bloodstream. Some come from her developing and growing uterus. Some come from the embryo itself, from the conceptus. But this new surge of hormones can sometimes cause an awful lot of the hairs on her head, just her head, to all grow in sync with one another, so that they all enter catagen and telogen at the same time. So in sort of the early and middle portions of pregnancy, a mother, an expectant mother, may actually start seeing more hair coming out of her head and ending up in, say, the bottom of the shower. But then, a few weeks later, still in the pregnancy, the hairs are going to start to grow back in sync with one another. And so the late-term mother may notice that her hair looks great because there's been a lot of new hair that has been growing out of her head from a whole bunch of early and mature anagen stage hairs. Right? So yeah, some hair falls out, but then it comes back, and all comes back at the same time, so the hair looks lustrous. Okay, so let's see, 7:55. Anything else I want to mention about the hair? Okay, we got the color, we got the growth cycle. So, oh yeah. There are two conditions I want people to know about when it comes to problems with hair. If you can't grow hair, then you have a condition that's called alopecia, A-L-O-P-E-C-I-A. Right? But if you have excessive hair, you have hirsutism, H-R-S-U-T-I-S-M. Right? Both of these things are typically genetic disorders run in families. And strangely enough, both of them can be caused by the same hormone, testosterone. Well, just to let you know, there's more than one kind of testosterone. The one that's responsible for hair growth is called dihydrotestosterone, or DHT. And so if you have larger amounts of that can lead to hirsutism, but go even further excessive, and it may be one of those things that can actually trigger early baldness and alopecia. All right, let's see. But I think that about does it for hair. So I'm going to close this particular video. Thanks for watching, and I'll see you when I come back to nails and then glands. So bye now. Stop.